Alright guys, I'm going to run through notes A and B with you today. I'm not here, obviously. So we're going to start the unit on polynomials. So the first part of the chapter is polynomial operations, and the second part of the chapter, which we'll do next week, is going to be all factoring. So up at the top left, examples of a polynomial. And not polynomials, you can see the main difference is the exponent. So any part of a polynomial, and backing up a little bit, nomial means term and poly means many. So a polynomial is a many terms. There you go. So if we look at the exponents, the main difference, of course, is that we have whole numbers on the left and integers and rational numbers on the right. So polynomials have exponents that have to be whole numbers. Negative exponents, remember, create a denominator, so those would not be polynomials, those would be what's called rational expressions. So a single term is often referred to as a monomial, meaning one term. Okay. The following are examples of monomials, so these right here. All positive exponents or a zero exponent, like that 5. And the degree of a polynomial, or of a monomial, the degree of a monomial is the sum of the exponents of the variables. And it's only of a monomial. So if we have a multi-term polynomial, we look at the highest degree monomial. So 6x to the third is a degree 3 monomial, 4p is a degree 1, and 10 is a degree 0, because technically that's like having 10x to the 0. 5x to the fourth is 4, 2a to the fifth is 5, and negative 5y to the eighth degree would be 8. So pretty simple. So polynomial is a monomial or a sum of monomials. So polynomials are classified by degree and the number of terms. So if the degree is 0, remember that would just be 1. It would end up just being a constant. So what we're looking at here is something like 5x to the 0. So there's 0 degrees. Or I'm sorry, not 0 degrees. 0 is an exponent, which is 1. 5 times 1 is 5. Okay, so that's a constant. Linear would be 5x to the first power, which would just be 5x. We know if we graphed 5x, we would get a line, so that's why it's linear. Degree 2s are called quadratics, like that. Cubics are degree 3s, and quartics are degree 4s. Typically, when we get above a degree 4, we would just start saying degree 5, degree 6, and stop calling them by their root Latin names. We can also classify these by number of terms. So those are the three that we typically would use. A 4-term or 5-term and anything greater than that we would just call polynomial. But the monomial, binomial, and trinomial have specific names. So a monomial would be something like 3xy. There's a monomial. Binomial would have 2 terms, maybe something like 3x minus 2. Trinomial 3 terms, so maybe x squared plus 2xy plus y squared. You can see that I can have multiple variables in any polynomial. Okay. And anytime you got 4 or more, we just call it polynomial. So, x to the third plus 2x squared plus 9x minus 3 would be a polynomial. Okay. So first part of the chapter, you just got to get used to the terms and classifications of these. So this first one is a degree 3. The name, okay, would be then a cubic. The number of terms we see is 2. It's really always one more than the operation symbol. And then that would be a binomial. So this would be called a cubic binomial. We would just put that together as the degree and the name. The second one down, that's a degree 2. So we look at the highest degree. We're looking right here, and we see that there's a 2 and a 1 in there. But we look at the highest one to talk about what the degree of the actual whole polynomial would be. So if it is a 2, that would be a quadratic. There are 3 terms, so that would be a trinomial. The next one, there's 4 terms, so we find the highest degree, which is right here. So that's a degree 4, which is a quartic. There's 4 terms, so we are just going to refer to that as a polynomial. So now write 4 examples. A linear binomial. So linear means what degree? Yes, it's a first degree and needs 2 terms. So let's call it x minus 2. Linear binomial. Cubic trinomial needs a degree 3 with 3 terms. So how about x to the third minus 2x plus 3. A quadratic monomial. Monomial means 1 term. This is degree 2. So how about 5x squared? And a 6th degree polynomial. Polynomial can have many terms, so I could write 100 terms if I want here, but we'll just start off at least 4 terms that has a 6th degree. So x to the 6th plus x to the 5th plus 3x squared plus 2. 4 terms, 6th degree. Simple as that. Now I want to do a couple other examples on the bottom. So if you just scroll down a little bit, if I just want to name degrees. So if I have 3x squared y plus 2x plus y to the 4th. When you have a polynomial like this, and you got 3 monomials and they all have different exponents and variables, what you're going to do is add your exponents. So the first term's degree 3, second term's degree 1, third term's degree 4. Find the highest one, and that polynomial then is a degree 4 polynomial. One more, if I got 5x to the 4th, y to the 3rd, plus 4x to the 3rd, y to the 2nd, minus 7x to the 6th, y plus 2x squared, y squared. So again, you got a rather long polynomial here. Find the degree of every term. So x to the 4th, y to the 3rd is 7. Then you got 5, 7, and 4. We find the highest number, which is the 7. So this is a degree 7. That's it. All right, so that's it for this one. From Notes B, okay, open up Notes B, and we're going to be adding and subtracting polynomials. So some examples, basically comes down to one idea called combining like terms. So here I'm going to add 3x plus 5x, which is 8x, and 2 and 3 is 5. So just combining like terms, and the classification would be a linear binomial. The next one, 2x squared plus 3x squared, is 5x squared plus 5. So that would be a quadratic binomial. Third one here, you can see that there's only one x cubed, so I can't add anything to that. 2x squared plus 3x squared is 5x squared. I do have a 2x, and then 5 plus 2 is 7. So I'm just combining like terms. So this is a cubic polynomial. Next three, I'm subtracting. So 2x minus 5x is negative 3x, and 3 minus 2 is 1. So this ends up being a linear binomial. 7x squared minus 5x squared is 2x squared. 6x minus a negative 3 is 6x plus 3. So this ends up being a quadratic trinomial. Third one here, I got some x to the fourth, so subtracting 5x to the fourth minus a negative 2x to the fourth is 7x to the fourth. I have some x to the first, that's 7x minus a positive 2x, which is 5x. And 1 minus a negative 2 is 3. So the degree here is 4, so that would be a quartic. And there's 3 terms, so it's a trinomial. We can also perform polynomial operations using function notation. So given at the top here, I have f of x being a quadratic trinomial, g of x is a linear binomial, and h of x is also a quadratic trinomial. So a, taking f of x plus h of x, so that would be 2x squared plus 3x minus 4, and I'm adding to that x squared minus 9x plus 2. So 2x squared plus x squared is 3x squared. 3x plus a negative 9x is negative 6x. And negative 4 plus 2 is -2. So this is a quadratic trinomial. G of x plus h of x, so that would be 5x plus 7 plus x squared minus 9x plus 2. So there's a positive x squared. 5x plus a negative 9x is negative 4x. And 7 plus 2 is 9. So again, this ends up being a quadratic trinomial. F minus g would be 2x squared plus 3x minus 4. And I'm subtracting 5x minus 7. So just make sure you're distributing that negative. I guess that's as hard as it gets today, is just making sure you're distributing a negative. So 2x squared, 3x minus a 5x is minus 2x, and negative 4 minus a negative 7 is positive 3. So classifying that, again, it's a quadratic trinomial. H minus f, so that's x squared minus 9x plus 2. And I'm going to subtract f of x, which is 2x squared plus 3x minus 4. X squared minus 2x squared is negative x squared. Negative 9x minus 3x is negative 12x. And 2 minus a negative 4 is 6. So this ends up, again, being a quadratic trinomial. So you're going to practice now. To practice 8-1 and homework B, just to make sure you got those. I left some answer keys for you. And then you just do your Math Excel for 8.1 today. Okay. And have fun with some polynomials. Have a good rest of your day.